Okay, hello everyone. Day is Europe 2022. Hope you are going to enjoy the whole conference because we have prepared lots of interesting talks and topics. And also we have with us some of the best speakers worldwide. So make yourself comfortable and enjoy the talks. Just to remind, at the end of the session, we are going to have some time for Q&A, and you can write your questions in the Q&A section. You can also use the chat option if you wish to write your thoughts or your questions, but it's better to use the Q&A section to ask Roberto whatever you want to ask him. Keep in mind also that our Knowledge Partner Pact will be giving away 20 ebooks to the most active conference attendees. So we urge you to participate and be active. Rate sessions, leave comments, ask questions, and you can win a great ebook from Partner Pact. Okay, let me introduce you Roberto Freato. Roberto has been an independent IT consultant since he started to work. After his master's degree in computer science engineering with a thesis about consumer cloud computing, he got specialization in cloud and Azure. Today, Roberto freelance consultant for major companies in Italy, helping clients to design and kick off their distributed software solutions. He also wrote some books on Microsoft Azure for K-12 education, and he trains, speaks for the developer community at many national and international conferences. And in the last years, he has been working as a chief technology officer for some e-commerce companies in Italy, and now for a leading company in the Amazon and e-marketplace services for brands. The topic for today's talk is implement a server strategy with Microsoft Azure. And it comes after a decade of innovation around big data, distributed file systems, data movement tools, and scalable data warehouses. And so Roberto wants to share his thoughts on how Microsoft Azure tries to wrap all this stuff with the new tools like Synapse, data lake storage, and more. And as a result, he will be implementing live data analytics strategy in a serverless mode on a consumption-based model. Roberto, over to you. Everybody enjoy the session.
Okay. Thank you very much, Emil. Thank you to my audience of today. Thank you very much to be here. And yes, as Emil said, I want to share my thoughts about how to approach data governance and to build the proper data platform inside Azure. As Emil mentioned, I started with Azure from the beginning, mainly focused on the application part. So I am a developer, and I want to share you how it worked for me, the transition, or better, the approach to enterprise data management as a developer. Okay, so this is my path also, and I want now to share my thought with you. Well, let's go ahead. A little bit of orienteering. So, introduction. What is the data governance? So, data governance is a set of actions, principle that in some way defines how we govern and how we monitor and manage the data and the data sets, the raw data, the good data, so the refined data and the insights into our companies. Okay, I usually say that the data governance is built on three pillars: the people that actually are using and not all just using, but also preparing, working on the data sets; the size of the company, that is really important to set up the proper data governance that fits very good to that size, to that environment; and of course technology. We are now talking about Azure, and Azure has Synapse, the Azure storage, SQL database, but of course the data governance really depends also on the technology, because if you are on another technology stack, you will probably use other technology and other tools. Okay. Apart from this, in recent years, we have We defined some principle that are
Roberto,
also called as data mesh.
Roberto, sorry to
Excuse me.
interrupt. Yeah, can you
Yeah,
reshare your screen because it's not seen properly? It's like cut in the
sure,
half. Yeah,
sure.
just stop and share it again.
Okay, now
I think it should be okay.
that's good.
Hmm.
Okay, good. Uh, Well, in recent years, we talk about the data mesh principle. What is data mesh? It's like the most flexibility that we can have in a company to deal with data sets. Okay, in a traditional company, we can think about the IT department, the not really a data department, but just the dev guys or the data guys that holds all the stuff in their department, from the sourcing part, so taking the data from outside to the databases and the data lakes, to the provisioning of the refined data set and the insights to the business lines, so business intelligence teams and something like that. Okay, but in recent years, to achieve more flexibility, we started to think about fluid organization with different teams for different domains. So I want to think about the data mesh in data as the microservices approach in application. So this is good, even if you are not really embracing all these principles. So I want to share this slide and leave to you, because if you embrace this principle, you are in the good path. You are in the straight path to be consistent and to be, of course, as much flexible as you want. So which are the principles I would like to enhance? To focus on the domains instead of the technology, so each domain can map um, 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 like a silos, okay, of data set, from the sourcing to the provisioning. Think about the data set as a product. So the good expert about a data set can be the, as in the product scope, there's the product owner, okay, for application. If you want to have a data platform that can grow and be also manageable, you can provide some sort of tool to self-serve your data sets to your internal and external customers. And each data set can, in a way, be integrated to each other. Okay, those are the principles to achieve a good data platform nowadays. Okay, but let's start to go deeper into the session and in the demonstration part. In this session, we're going to use some fictitious reports, but they resemble my work around the advertisement platforms I work on. So this can be three types of reports for clicks, conversion, and impression. If you work in the advertisement space, clicks is just a measure of the clicks that people makes you on a product, on a banner, into a web page. Conversion is the metric that tells you how many user converted, so made an order or a specific action that you want. An impression is like the showing action of a banner, of a creativity to the end user. Okay, so I generated some fictitious data of these three types, and we are working on them in this session. This is what I want to share to you is this typical data strategy evolution. If you start from scratch and you start small, if you start small, you won't probably go direct to a data lake storage, Spark engine, Databricks, and so on. You probably start with something simple like a relational database, like storing JSON somewhere. So storing JSON, I mean storing the raw data somewhere, to then go ahead and complex your stuff. I mean complex, it means adding features and adding something that, of course, will complex your situation, but also will solve problems, harder problems, of course. And I want to show you the technology under this typical transition. Okay, so in the first part is ingestion. I wanted to write some C# code for the ingestion because it's nice for the GitHub purposes, so you can clone the repo and try it by yourself to your storage account in Azure. But of course, ingestions is a very different, can be a different scenario. You can ingest from API, you can ingest from like an event broker like Kafka Service Bus. You can ingest from several different sources nowadays. So let's see how I did this just to show you. I implemented this fictitious sourcing service that is generating these three report types. Okay, the generating part is in this code, so you can easily go there and change the logic if you want. And then for a date range, I wrote these reports to a relational database. I wrote it first because it's a long running task, and then I'm going to write all this report even in the data lake. Okay, if we can go to the relational database, we can see these three tables. Okay, clicks, conversion, and impression with the relational, the traditional relational model. So what I mean with traditional, I mean columns. Okay, columns with data types, with strong typed fields. Okay. But if I want to save them into the data lake, I need to identify a data lake. And in Azure, the data lake is the storage account with the Gen2 option. Okay, so I previously created the storage account with the hierarchical namespace enabled. That it means that can be a data lake. Okay, and if I take the key, okay, not really the connection. Okay, and I specify a prefix for the path, like this. I can run this ingester that is generating all the reports and saving them into the data lake. What is saving right now? Let's dig into the code. The first version is just a file storage. So for each report, I'm just saving, sorry. Okay. I'm just saving into this folder the JSON, the resulting JSON with just a GUID. What I want to teach you about with this process, if I go to the reports and the dev days part that is growing up in the seconds because it's running, okay, I can see that here we have just a lot of files in a non-structured folder architecture. Okay, this can resemble the landing part of your ingestion phase. Okay, if you heard about the landing or the staging space is a place when you just ingest all the stuff to then perform a sort of filtering, organizing. So this can be a good point to ingest fastly into a specific portion of the data lake what you are taking from outside. The second form we are writing into is what I call partitioned data lake. So in this partitioned approach, in this other folder, I will write this blob, this file, with a folder that specify the type, so click, impression, and conversion. And I also specify a partition by date, so year, month, and date. So if we go to that partitioned part, we see folders, and this is good, and we'll discover why this is good, okay, in a few minutes. But now all the files are organized into those folders. We have just January because it's running, okay, so we arrived to the, okay, 31, so I'm expecting we also have February live, okay, because it's writing, okay. And inside here, we have two kind of reports. Why? Because coming back to the code, in the first one, I just write the report JSON as it arrives from the source, okay? But in the second part here, I also write it in the Parquet data format. What is Parquet? Probably many of you already knows it. It's a columnar format, so data is not plain text, but is stored as columns, and that columns are compressed a lot. So it resembles so much the cluster column store in SQL Server or any other column store engine. So column store engines are really designed for analytical purposes and big data because of the size, and because we often need to aggregate and perform some averages, pivot, group by, that works really good with column storage. And a last way to write that is really specific to the blob storage but is really powerful is the append mode. In the append mode, I do not write a single JSON object for a given report, but I append all the reports that are coming into the same JSON object with a specific storage API that is called append blob. Okay, in that case, we can see the append blob for a specific year here, like let's take the clicks one, that is growing up. Okay, let's give it, okay, a second, that is growing up report by report. This is a good approach also because we have not so many files to manage. We have just one or many, it depends of the items, okay. So it's a good approach if you want to ingest in a single file by appending the content record by record. It's not possible with the Parquet because Parquet is columnar and is compressed, but with the text files like CSV and JSON is a good way to ingest your data. Okay, after that we can stop it. It's enough. Okay. And we saw how ingestion work in this demonstration, of course. Now I want to introduce Synapse Analytics, that is a set of both existing technologies and new technology under this brand. Microsoft wanted to take into this big container a huge set of technologies like Spark, like the former data warehouse that now is called a SQL database dedicated pool. It also contains Azure Data Explorer. It contains some tools to dig into the data set, to make pipelines. So it contains Azure Data Factory also. And as we can imagine it as the container of the most important data technology of Microsoft Azure. Okay, so let's see it in action. We can come back here, and this is Synapse. We have an home page. We can connect some sort of external storage sources like the storage account, the SQL database. This is a concept that stands for a lake database, so an abstraction that let you read a data lake as it is a relational database. Okay, but let's go to the reports part. We can see the content even here. Before we were on the Azure portal, but now we are in this managed environment. So we can go into the dev days. We can go like here in the batch and preview some contents. We can also perform some interesting things like, for instance, let's take this one. Let's take JSON, and we can query the data lake as it is SQL. Let's give a try here. And this technology is called Synapse Serverless Pool, because it's like a bridge between the relational world, that is the output, and the data lake world, which is files. Okay, so in this case, I see just a column, but I can perform a cross apply, open JSON of JSON content, and project just the value part. And with this syntax, I'm exploding the JSON array in items. And after that, I can also say, hey, take out from the value part the node like country as country, something like that. And this is how I can create a view, like a view that transform in real time our data lake files into a relational format, and I can connect and I can use this. So if I can like take this SQL, and I can also use it inside my endpoint that is TDS enabled. So we can use it from applications if you want. We can do the same with the Parquet, and the Parquet also internally stores the schema. So it's not needed to cast single specific columns to their data types, because they are already strong type. So this is really good. And it's not really working on a single file. We can also say, hey, take all the path and explodes all the wildcard of this path. And I can also promote this path, saying, okay, in addition to star, I want also the file path one, and as here, for instance, star. Okay. So this is an API to promote the segment of the path as field. So the application can be this one, for instance. So take the first one, take the second one, take the third, and pass to this as date, for instance. Okay. And we can introduce in this way surrogated columns that can be used after that to filter that data. And when you filter that data on this expression, the underlying engine will filter also the underlying folder. So it's a real good pattern to achieve. Okay, but this is just the serverless pool. We can also develop the SQL script notebook in Python like this to read the Parquet in PySpark and perform a complex manipulation. We can create pipelines that are the composition of tasks in an UI environment, and of course we can monitor all the stuff and pay for the services. So this is a brief introduction, and now I want to show you how to consolidate your data set. So we have some alternatives. The first one is the data copy, the simpler one. Then we can use data flows or even Spark pools. We can also but it's not really a suggested approach. Consolidate data through the Synapse serverless endpoint. You saw that with the SQL query, we can read from the data lake. So we can also put all the stuff together in a single query and then use the query from outside. It's a good approach. It's not a recommended one. For consolidation, it's good to read data to make some sort of exploration, of course, but if we have tons of files, a million of files, you can't simply reading it with a serverless pool. It won't work. So you should need to consolidate them with a data copy activity or data flows or a Spark pool. The difference is that data copy is just like think about it as an appender. Okay, so data copy can work if you need to append a data set of type text. Even Parquet works, but just similar, not similar, the same format or Parquet. If you try to copy one Parquet type and under another Parquet type, it won't work. For that, you need a data flow. A data flow is something complex that you can, where you can specify the schema drifting, you can perform some advanced mapping, you can say, okay, this field would be renamed to this one field and convert the type to that one. So data flow is something complex and is based on Spark. So the third thing is if the data flow doesn't fit your need because your need is too complex, so you can write code, you can directly write code in a Spark pool. So your code could be Python or even .NET for Spark. But of course, you should need a code-based approach. So if you prefer a UI-based approach, the data flow is better. So let's try to consolidate our data set right now. Where is it? It is here. So let's close some script. Okay, good. We want to consolidate the clicks. It's okay. Okay, so this path. So let's go there in the pipeline and create a data copy activity. Here we say create a new source that is Gen2, that is of type Parquet, that is in the service that I already created. This points to the storage account, so it's something that you can just create once. I don't specify any parameters here um, to fix all the stuff here. So here I would say to go to the reports container, and I want, let me a second, dev days partitioned type clicks. So dev days partitioned type clicks. Okay, slash here everything, month everything, day everything, star.parquet, and let's preview the data. Okay, it works. But if I click this magic button, I also have promoted the path segments as columns. That is good. Okay. So I'm taking all the stuff from the many years, many months, many days, and I want to produce a single file. Okay, it's not really a production requirement. Okay, because in production you probably would like to consolidate into months, into days, into years, into quarters. Okay, not really a whole file for all the stuff. Okay, but in this case we do like this. So the output can be on the data lake storage as another Parquet on the same storage account. It's not a problem. And here we say that we want in the reports file, in the dev days folder, slash partitioned, I want a file that is called type clicks.parquet. Single file. So I need to go back in the pipeline and say that it should merge all the files together in a specific file. I debug this activity and it's actually allocating the data unit integration, no, the data integration unit, excuse me, that are like computational engine that performs these activities. So it is in progress. So in some seconds, maybe we will start to see the files that have been read from the storage, okay, and write to the output. So if we come back here in the partitioned part, we have this parquet, and we can use it in a consolidated way. We can also perform some complex logic. So if we want consolidation on a type based, so one file for the clicks, one file for the impression, one file for the conversion, we don't need to copy and paste this copy activity changing the names. We can perform something smarter, okay? We can say, hey, get the metadata from well, create a new one just to avoid making mistakes during the demonstration. Okay, so let's try to list what is in the reports dev days slash partitioned star. Oh, not really. Okay, this can be enough. And I want the child items. So let's try to debug this. Let's stop it. And let's see the output. This get metadata activity is like is something that is technology aware. I can integrate with different sources to get metadata. In this case, the child items means listing. Okay, so we can see all the stuff. Oh, I mixed also this parquet, but we can filter for the type, for instance. Okay, but to be smarter, I can go there and delete this one for a second. Okay. So I'm producing this child items with an array of folders. Nice. So I can say, hey, for each for each for each child items in the output of the previous activity, perform an activity. Which one? This. So I remove the activity from this plane. I passed it here. But now I can use the parameter, the current item, here instead of this fixed item. So I take out this fixed string and I use a concatenation pattern here to say, hey, concatenate the current item. The current item is the tuple name type. So I just want to use the name part. And even in the sync, I say, not here because it's mixing stuff, that should be the parameter. But this is another object, okay? This is a data set. So how to pass the type, the variable that we have here in the data set, we can promote this as a parameter. So we can create a parameter name. We can take this out and fill it with the parameter. Now the data set is parametric. And here I can specify dynamic content. Well, actually, concat of this dot name, item dot name, and extension. Okay. So let's run all the stuff, and I'm expecting now it works with those three different folders producing three different files. The good thing is it is parallel, so the copy data is not sequential, and it will be faster in the case you have many folders and it's a very concurrent service. So think at it as an enterprise service to consolidate data. Okay, is succeeding. Let's hit some seconds more. Okay, so I'm expecting that here we have those three files. Good. So we use the data copy activity to consolidate, but now let's introduce the next problem. The next problem is if we have different schemas and we want to merge them, think about merging clicks, impression, and conversion to have some sort of aggregates, okay, between them. The data copy will not work because it's not working with different data. So we need a data flow. So let's investigate how it works the data flow. Let's go here. Let's cancel all this stuff. Let's introduce a data flow and create a new data flow. Okay. Well, we can start from the source we already consolidated. So let's take the parquet, create, yeah, the linked service is okay. And let's go where to reports slash dev days slash star.parquet, or even type equals star. Better to filter properly. We can specify the compression that for Parquet by default is snappy. And we can make a preview, but I forgot to start the data flow debug before the session, so we'll take around 1 minute, something like that. So in the meantime, we are designing the data flow. So after taking all the files, that can be even many, okay, in this case they are 3, but can be many, I want to select just the fields that I need. So I will introduce a select part. And after the data flow is started, I can also auto-generate all this mapping to avoid to perform it manually. What it means that I can say to add the mapping from, I don't know, country to country, or there also a country code in another type, the conversion one probably, and I can convert it to country just to normalize that names. And I want, for instance, to map also the cost column into an output column. What why I'm using the select operator? The select just project some fields instead of the whole things. So it's a good point if you just need those columns and not the other ones. After that, I want to integrate an aggregation. So I can aggregate the, yes, I don't see it because it's not really running, but can aggregate, for instance, the country from all the 3 report types to provide the total sum of the cost. And then finally, I can write the result somewhere else, maybe into the database, into the relational database. So let's configure it in the meantime. I can say, okay, go to the database. Use the database we already created in the subscription, which is this one, okay, with these 3 tables. And let's specify the managed identity. That is a way that Azure used to connect services between each other to avoid the username and password. Okay, let's what it's missing. Okay, the database name, demos. Let's test the connection. It works. Good. In the meantime, the debugger has started, so we can have a data preview. It's a matter of seconds, actually. Hope so. Okay, in the meantime, I'm also importing the schema to save some time. Let's see if everything dev days type, dev days type. No, yeah, it's good. So it's just a matter of waiting. Okay, the schema has been imported, so I can go ahead and I can also recreate it to let you know that I have all this stuff by default. So I created manually, but it's not really needed. Transformation fails. Okay, no problem. We can do this again. We can just create, take what we want to keep. This can be normalized. We can make a data preview of this step. In the meantime, I hope that data preview here worked. Okay, it worked. Hope it's working here. Perfect, but country. Okay, country is not working. Why? Let's try to refresh. Country code, country. Well, okay, not really. Okay, because it's country code. Good. And now let's make the group by country with grouping the cost column with some expression. I will write it here. Let's debug it fastly.
Just to let
Yeah,
you know that we have 3 minutes left,
yeah,
and I
exactly.
urge the audience to ask questions if they have ones, to post it in the
Okay,
Q&A section.
sure. So I skipped this part, but I'm sorry about that. I just need to fix some things, but it will produce a table here. And I want to leave you with the idea of the Delta Lake. So the capability to move all the storage directly to Parquet in a updatable way. So for instance, we can have like here we can create Delta Lake with this syntax base. Okay. And let's stop it. Okay, perfect. And in the meantime, it runs. I can reply to your questions, and in the meantime, I will complete the demonstration. So, if you have some question, you can post it in the Q&A. Otherwise, let's wait this. What I'm doing here, I'm creating a fictitious table inside the data lake that can be uploaded, updated as it is SQL, okay? Not from a typical traditional SQL engine, but through PySpark and through PySQL, okay, into Spark SQL. And the underlying data format is Parquet. Okay, this is a very impressive approach if you want to avoid to deal manually with the activities of modifying Parquet, modifying JSON files. So this is something that comes from the Databricks world, and it's integrated into the Synapse environment. So this is the takeaway of the session. So after coming from the relational part, consolidating data, using the data lake, digging into JSON and Parquet, and reading it from the serverless pool, you can also work directly into a Spark pool to avoid the relational anymore. Is it possible to use Postgre for Azure integration? Of course, Postgre is a relational database that is supported. So, for instance, we can come back here and say that instead of this one, we can have Postgre. Okay, this is Azure database for Postgre, but if you can also specify a plain old ODBC connection. So if there is a connector for that SQL engine, it is supported. What we have seen in your demos are Azure Data Factory in action. Is something else that is part of the new Synapse Analytics? Well, Synapse is a collection of services. So it's that was ADF, but for instance, this is not part of ADF. So when you write a Delta Lake under the hood, you are creating this situation. Well, okay. Of course, we have some issues. Okay. Okay, execution in progress. You are creating something into the data lake, and it's not possible through ADF. It's something that we can perform even just in Synapse. The other thing we saw in this demonstration is the capability to read the Parquet or the JSON through this SQL syntax. And this is not ADF. It's this bridge that is called serverless pool that is integrated into Synapse. So these are two things of Synapse specifically. Of course, the pipelining part. So this one is ADF. Okay, but you can also integrate custom database, so an Azure Data Explorer database that is Azure Data Explorer. So think about Synapse as a collection of existing services with some new pillars, like this one, or even the capability to run Spark notebooks inside it. In this case, we created a table that
Roberto,
looks
actually,
like
we're running out of time.
sure.
Thank you very much for the great presentation. We had two questions. Thank you very much for answering them. It was very
Yeah,
interesting. Thank you everyone for the attention,
sure.
and see you in the next presentations.
Thank you.
Thank you, Roberto.
Bye bye.